In the comments of the last video, someone said my hair looks like their grandma's. And to that I must say, your grandma knows what's up.
Ah, my very own 3D printer. Now I can make anything, like these little boats and flexible animals. It's got all these gears and pulleys and all these different build plates.
Until your wife asks why you got a 3D printer. And then the pressure's on. The pressure is on to prove that this machine truly can make anything. So you ask her what she wants, and she says this. She doesn't say something simple. She says this. It's a tall order, but we are not quivering in fear. We accept this challenge gratefully. But then the realization sets in. We have almost no experience in CAD or model design or 3D anything except for our slicer. So while we could learn Fusion 360 or SolidWorks or some form of CAD design, we're on a time crunch. Valentine's Day is next week. And I also started this project a month ago. But here we are. And we're almost done. But I'm filming the intro of this video almost towards the end because I truly didn't know if this was going to work until right now. So let me walk you guys through every step of this process. First, how are we going to make this thing? To answer that question, we're going to use one of these, an iPad Pro, and we're going to draw this mother. So the iPad has an app called Shaper 3D, which will let you have up to 2 projects on the free version for non-commercial use. So with Shaper 3D, we can actually go ahead and draw our design on here. So you can see that I took a picture of the inspiration, the original creation here. This is from like over a decade ago, is the last time I could find anyone that had this thing. They make this thing out of wood, and then I drew over it, and you can see I cut some shelves out. So here on the right side, there are some shelves that I did not want in our final designs, and here we are. So this is kind of like my remix, and I selected what parts we would like to extrude, and then I extruded just those bits. So that can be used to give us an STL file. Now, if you're not using Shaper 3D, you can draw this in an app like Procreate. You can even draw this on a sheet of paper, scan it into an actual real printer that prints paper with ink, and you can take your drawing and upload that to a place like Convert.io or some website that can convert a PNG file to an SVG. And then you can take that SVG and put it in an app like Tinkercad and extrude it there without needing to use Shaper 3D at all. So if instead of using Shaper 3D, you're using Tinkercad, this is what that would look like. So here I have the same heart shelf. From there, with our SVG file now in a 3D model, we need to proportionally scale it. And there are a lot of drawbacks to doing a method when you're drawing a PNG and converting it into an SVG. First off, everything that you're scaling is proportional to the object. And what I'm trying to explain here, on a 3D model that you CAD design, you can take a part of it, a face, a segment, you can extrude it, you can, intersect it, all these kinds of things. On a model that you have already made into an STL, really all you can do is cut it, add on to it, add negative spaces, make it bigger or smaller. But when you increase the size, you can either stretch it or you can increase it proportionally. Or on a 3D model in a CAD program, you can say, I want just this one section to be enlarged, or in our case, on the shelf we're making, maybe we want one single shelf to be thicker than all the other ones, which once we have an STL, we can't really do that unless we add something like a box onto this and then stretch that box as a positive part to then be in the slicer as a single object there. So here we have the heart shelf on our slicer, and as you'll see in our model, we don't have a background to this object. So to quickly fill that in, all I did was I put this in the Procreate, outlined it roughly, and then extruded, I turned that outline into a PNG, into an SVG, and extruded that in the slicer as a single STL. Now that is a really lengthy process just to get the background that is on this heart shelf here in our slicer, but that was the simplest pass for me since this object is more organic and isn't like a square or a cylinder, for example. So with this, we can now go ahead and check out here how many build plates this took. As you can see, we ended up doing 4, 8, 12, 13, 14, 15 build plates here for the heart shelf. Now, how many rolls of filament did this take, you might ask? And unfortunately, it took 8 rolls of filament. And it originally would have taken 7, but there was a lot of errors and a lot of problems during this project. First of all, I was just recovering from my issues with Bambu's previous firmware. Then, with the previous firmware, I built the BLV riser. So if you guys haven't seen the previous video, please go check that out. The BLV riser itself introduced a lot more problems than we had before. First off, the BLV riser raises the AMS, and when you do that, you're putting tension and more strain on your PTFE tube that connects the AMS to the AMS hub, which then feeds into the P1S printer. The problem that adds is that when you take that PTFE tube and you stretch it, you start to get sharper angles, and the filament has a much harder time going through that sharp turn. And what that ends up doing is the filament gets too much resistance. And when it gets too much resistance, it will stop feeding into the P1S and it will try to load the filament, get almost to the nozzle, and then it'll start to retract and say that it was unable to feed the filament. And that caused a lot of problems. So what I ended up doing was just brute forcing this at first, right? I would load the filament manually, and then halfway through the heart shelf, it would need a color change or something like that. And it would try to unload and fail to unload, and then it would try to reload, and you'd have to come and manually do it. And sometimes the print bed would start to separate because it had been sitting for 12 hours overnight while I'm sleeping and things like that. And then we started to have a lot of weird issues where the filament would get clogged in the nozzle, so I had to change nozzles at some point. Basically, you name it, we ran into it on this project. But ultimately, we got all these pieces printed out. And it was a lot of printing. So let me go ahead and slice this here, and we will just see how long it says this is going to take. Also, can we talk about how fast the M1 devices are? I mean, look at this iMac Go. It is just burning through all 15 of these plates, and it did it pretty quickly, 13. So according to the slicer, this is going to take 5 days and 23 minutes. And I feel like that's very accurate, because each of these prints are 8 hours plus, except for 1 or 2 of them, which are 3 hours or 4 hours. So, printing montage starts now. Okay, so here she is in all of her glory. This is our 3D printed shelf. Let me get it up on its side just so you guys can see the scale of this thing. You have to be very careful when moving this. Okay, there we go. Is it all in frame? No. Let's fix that. Okay, so here's the heart shelf completely finished. Let me swap sides. Like, this is where I'm sitting. Bradley for scale. This thing is like, I mean, here's my arm. It is massive. Let's get a measuring tape and see exactly how big we made this. So that was another part of this. When scaling this proportionally, in the Shaper 3D application, I can see how big it is roughly. So I was able to guesstimate the size. If you were to draw this, you kind of just have to scale it in your slicer, and the slicer will give you the dimensions, and you just have to hope you're getting, the size you want. We ended up making this almost, well, let's see, 27.5, just over 27.5 tall. And at the widest part, it's roughly 27.5 again. So oddly accurate. But that is because we modeled it in Shaper 3D and didn't do just the drawing, except for the back. The back is drawn. So we did draw the back and fill that in and add it as a partner slicer. Now this didn't turn out perfectly. There are quite a few problems. So first, you can see the infill in some of these pieces. The other part is we had some layer shifting. So the SuperTack build plate was unfortunately detaching in the corners. I have since figured out how to use mouse ears in my 3D print, which I plan on making a video about, and that has fixed everything for me. Other than that, we did have some areas where there are slight little bits of filament that got stuck in there that we need to get out of here, but that's no big deal. And then obviously with 15 different pieces assembled together, you have all these seams and creases. So the state that this piece is in right now, it has been glued together with E6000 Premium, and it also has wooden dowels inserted throughout. Now I used oak 1/4 inch dowels, and the reason for oak is it's pretty strong and pretty, it's slightly flexible given that it's 1/4 diameter, but it's the strongest thing we could do without going into something like steel rods, and it's also the smallest object we could fit in these thin shelves that would still give it rigidity. Most of the dowels are left to right. Some of the dowels are top to bottom. The ones that are top to bottom are mostly shorter than the ones that are running left to right. Each piece also has these holes for mounting to the wall. So the plan is we're going to do probably about like 15 drywall screws. Don't tell the wife that part. Anyways, the 15 drywall screws will hold up each section itself, but also horizontally the sections that have the long wooden dowels, which were, about probably like 24 inches long from left to right, because they span from about like an inch or two in on each side. So yeah, about 24.5 inches across the print. Now it does have all the blue and red masking tape on it right now. That was holding it together while it was glued. So the only other thing that will be holding this together other than the glue, the wood dowels, and the drywall screws is I may put some solvent on the back, and that might help melt the plastic, but I don't think that's going to really add any structural integrity, so we might skip that step. We'll see. And then the only other thing we could do is fill in the seams, which would be possible. We could Bondo the seams. A lot of cosplayers will do this with helmets. So when you 3D print a helmet, you'll usually Bondo it. Then you will filler primer the helmet and then sand it down and then paint it to get a smooth surface. The problem is I'm not very good at that. And even with the helmet, it takes me a couple weeks to get it perfectly smooth. So on this heart shelf with all this complexity, it would probably take a long time. And it is kind of cool to keep all the seams to be able to tell that this was clearly 3D printed because it is part of the charm. So the only other thing to do is to get this bad boy on the wall.
I'm gonna go get that stud.
Pretty much right where that screw was is
The center of the wall.
the center of the wall, yeah. So do you like it like right here?
Yeah, honestly, who's gonna hold me or you?
Feet for free.
Actually, let's see how heavy it is. Let me go grab the scale. All right, let's see. Without the shelf, I'm a brisk 207.8. Okay, with the shelf, I am a brisk 2.3. This thing weighs 16 pounds. Okay, so drywall screws, we're doing these two. Like put the level where that center hole, like, yeah, move it.
Like, is there some kind of...
This is the Prusa
So, cool.
La 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 la. I run this.
Do you wanna, you said you wanted to hold it?
No, you said...
Just like that.
Oh, it's magnety.
It is magnety.
That's the best screwdriver I've ever used in my life, by the way.
Isn't it awesome? I love it.
Whoa! Turbo mode. Ta-da!
Today's video is sponsored by Easy Drywall Anchor. No, I'm kidding.
We need the little hole covers.
We do. I'm gonna print 20 of them real quick.
You don't have them?
No.
What the hell?
It'll take me like 2 minutes to print them all.
Let me see it.
Marshmallow.
Yeah, go put that marshmallow in there.
Okay, here's the new version.
Yay!
Okay, I've got another one. Version 2, 3, whatever this is.
Bro, I swear nothing's changing. No, but like, if I push it in there, it's not gonna come back out. Feel how it feels. Just don't push it all the way. Did you put the right side in? Oh,
Looks perfect to me.
okay. Maybe it was how I was putting it in. Maybe I'm just dumb. Don't answer that.
You can't even like tell where it is. It's awesome.
Oh, there's another one up there.
Oh, wow.
I didn't see him.
Neither. I don't think I counted that one.
Yeah, we didn't even mark that one. So we need 12 more.
1, 2, 3, 4, 5, 6.
I'm just gonna make 12. Mm-hmm.
So here we have the shelf completed. We have all of our jelly cats on here, courtesy of Megan. We've got the frog, the potato, and Clemmy, and the bee, and the Rumblican elephant. Everything we wanted on there. It came out super great. This is an awesome Valentine's Day present for anybody, and I know it took a super long time to print, and it took 8 kilograms of filament, so about $170-ish, and overall, it looks really good. There's only a few seams that show up on the outside edge there, but once you have all the jelly cats on there, you can't really see the seams at all. So yeah, everyone let me know what you think in the comments, and would you print one of these for yourself or for someone that's important to you?
I know a lot of you are going to want to make your very own heart shelf, and I think that's great. I'm not uploading my exact model files, however. The reason being they're a direct derivative of someone else's work, that being the range.co.uk's white heart shelf. I think my tripod's moving. It is. Hold on. There we go. Hopefully no more moving tripod, maybe. With that being said, I have made my own version of a white heart shelf that is available for you all to download for free. The other reason is my white heart shelf is 15 plates and 8 kilograms of filament, which I think very few people are going to print. So instead, I've made a much smaller version that you can fill the entire build plate of either a Prusa Mark III or Mark IV-S or a Bambu Labs P1S or P1P. This shelf will mount on the wall with 3 drywall screws, and you can move those screw holes if you want, or put them in different locations, or just fill in the negative space of the cylinder if you want to command strip it to the wall. Just make sure if you command strip it that you print this on a smooth plate, that way the surface is perfectly smooth on the back and not on a textured finish. Rather than printing one of these white heart shelves at the full scale, I have printed one at approximately 30 grams of filament, so it is much, much smaller, but that way I can show you all what this will look like. So here it is, the itty bitty, super tiny, mini version of the white heart shelf. So you can see that this version, let's get the focus on here. You can see that this version has a screw hole down here and then one under each section of the heart, and it supports the same hole filler method that I did on the full-size heart shelf. It has 2 shelves at the top, 1 big one in the center, and then 2 at the smaller one. So ideally, you would print this to be the size of your build plate and then be able to mount this on the wall with some drywall screws. At that rate, it would take about half a kilogram of filament, and I'd recommend using 3 walls, maybe 4 if you're feeling generous, and at least 10% infill. I used a grid pattern on mine, but feel free to use gyroid or whatever infill you prefer. Thank you all for watching, and have a great rest of your day. Also, those files will be available on Printables and Makerworld. I'll link them in the description below.
Don't show my toes for free!